Hello my friends! Today I want to talk about our atmosphere and especially about oxygen. Oxygen is needed by our body to perform its functions like create energy, digest food, clean toxins, fuel the body's muscles, strengthen the body's immune system and a big list of other things. Everyone knows how important oxygen is for humans and animals. So I went on Wikipedia and Wikipedia tells me that oxygen was discovered by Carl Scheele in 1773 and Joseph Priestley in 1774. So we knew that we lived on a globe even before we discovered the stuff that we breathe, and we discovered it twice. Please don't ask me to explain that. Science tells me that the atmosphere of Earth is the layer of gases, commonly known as air, that surrounds the planet Earth and is retained by the powerful, godly force of gravity. Our atmosphere contains on average 78% of nitrogen, 21% of oxygen, 1% of argon and a few other small amounts of various gases. I never understood that there is only 21% oxygen, while it's the stuff we breathe and the stuff we need. So I started to wonder what would happen if there was more or less oxygen. Well, it didn't take much research to figure out that if you remove too much oxygen, people just die. But it seems that if you add more oxygen, you get some amazing results. This article was posted in 2013. Big insects provide big answers about oxygen. Johan van den Broeks has raised dragonflies that were 15% larger than their normal size. Approximately 300 million years ago, creatures on Earth lived in oxygen-rich environments. These high oxygen levels peaked around 31% compared to 21% oxygen in our atmosphere today. According to the fossil record, this resulted in some pretty big bugs. A bit further in the article he says, I thought to myself, it's really hard to interpret any of this, because we don't have an understanding of how oxygen levels affect anything today. So how are we supposed to understand what's going on in the fossil record if we don't understand what's going on now? To answer this question, Van den Broeks began rearing alligator eggs in varied concentrations of oxygen and analyzing the development of their embryos. The changes he saw in modern alligators correlated with those in the fossil record. Unfortunately, alligators take 17 years to fully mature, making them less than ideal for laboratory work. Van den Broeks began rearing insects in 3 different environments, imitating various oxygen concentrations throughout time. A 12% oxygen atmosphere, today's 21%, and the oxygen saturated 31%. The dragonflies responded to the high oxygen levels in kind, swelling to 15% larger than those reared in normal oxygen levels. In low oxygen, the dragonflies ended up 20% smaller than today's typical size. They say that oxygen is toxic at higher levels over time. It affects the central nervous system, the lungs and the eyes. But this is a rare condition seen mostly in deep-sea divers, and I don't really know a lot about it in terms of exposure times and concentrations. I would say that the big disadvantage is that it makes things burn much faster. Carbon dioxide is a well-documented limiting factor in the growth of plants in laboratories. And since the concentration of nitrogen in the atmosphere has remained almost constant, the higher the level of oxygen there is, consequently the lower the level of carbon dioxide. Director of the Creation Evidence Museum in Glen Rose, Texas, Dr. Carl Bach, has invented and patented a hyperbaric biosphere chamber to test biblical claims regarding pre-flood atmosphere and magnetic conditions based on Genesis. Genesis states that life on Earth was created perfect and designed to live forever. it also states that after the fall of man, all elements of which everything is made were cursed. Genesis then records a gradual degeneration of the whole of creation until the flood of Noah, followed by an increasing rate of degeneration as time progressed. Anyway, in this chamber he made, the oxygen level is between 22 and 30%. Experiments carried out in this pre-flood atmospheric chamber have produced amazing evidence supporting the biblical record of the pre-flood world. Some examples include extended lifespan of fruit flies up to 3 generations, accelerated growth of piranha fish from 2-inch to 16-inch over a 2.5-year period, and molecular change of venom in copperhead snakes to a non-toxic state. These pictures show how the structure of the venom changed in only 4 weeks. It's the venom of the same snake. It has been estimated by researchers at the University of Illinois that the atmospheric pressure in the earliest beginnings of life on Earth could have been as much as 29.4 pounds per square inch. That's twice the current sea level pressure. Oxygen content would have been about 30% instead of the 21%. An open wound could heal overnight under these conditions. This would support human life lasting several hundred years. A related post sent to a discussion list recounts the following unconfirmed information about the effects noted by aquanauts living underwater for periods of 30 days or greater. CGT Enterprises 1 wrote, "Hi everyone. A friend of mine who worked for the NSA related an experiment that was conducted by NASA. 3 scientists lived on the floor of the ocean for about 1 to 3 months in a biosphere. When they left, they were all middle-aged with graying hair and low libidos. When they returned, their hair was clear of gray, their wrinkles had started to disappear, and their sex drive was so increased that their wives complained to NASA about it. It turns out that certain glands and organs were reactivated. One in particular was the gland that lies over the top of the heart. Blood tests showed unusual hormones, hormones that are normally associated with the growth of young children." And now I want to show you a short clip of the guys that made the Biosphere Chamber. Their YouTube channel is Creation Evidence Museum. They have some interesting things to say. Let's watch it.
That if you increase the atmospheric oxygen to simulate what we had before Noah's flood, the entire blood plasma of the whole organism, the whole body, is saturated with oxygen, the entire blood plasma. That solves major problems. For instance, you and I genetically, during gestation, during the 9 months of gestation, you and I genetically produced 200 billion brain cells. 200 billion. But we ended up with 100 billion. And we're doing pretty well with 100 billion. We can get to space and back pretty well, and we can learn to count, and we can do some good science, and we can fly artificially. Doing pretty well with 100 billion. But what happened to the other 100 billion? Texas A&M discovered, others had published on it as well, that a brain cell dies in 6 to 10 minutes of oxygen deprivation. So in today's atmosphere, today's context, the blood plasma is not saturated with oxygen. The hemoglobin picks up 4 oxygen molecules, that's all it can take. But the blood plasma is not saturated with oxygen. So here we are, here's this mother gestating her child, laboring to get enough oxygen for herself, transferring as much oxygen as possible to that kid, but can't give him enough. So during the third trimester, just before the child's born, the last third before the child's born, there's a tremendous proliferation of brain cells. Millions of new brain cells every day. Millions, but almost all of them die. Why? Can't get enough oxygen. The rest of the body's taking it all, and the brain cells already there. The brain uses over 20% of the oxygen that we take in. So the brain cells already there are taking all the oxygen, so the new ones can't get any. So we end up with 100 billion brain cells. What if we, and we're not going to run human experiments or primate experiments in the biosphere, but what if we had 100 billion brain cells? Would we be twice as smart as we are today? No, a lot more, because every additional brain cell, every brain cell has from 10 to 50,000 neuron connections to other brain cells. So the difference between 50,000, between 100 million and 100 billion and 200 billion brain cells is light years.
For some time, medical hyperbaric chambers have been used to fasten healing of skin injuries and various other diseases. While many hospitals contain a chamber like this one, professional sports teams and celebrities have increasingly been experimenting with sleeping in enhanced oxygen and high pressure. Evidence is mounting that these chambers can reduce infection, heal diseases, decrease stress, and enhance stamina.
Well, my name's Doug Jones. I'm a science doctor at the University of Reading, and I run a clinic which deals with sports injuries for elite athletes and normal ordinary folks. And we do have a speciality of leg ulcers. We're very fortunate that we have a hyperbaric oxygen chamber, which we have as a facility here, which makes us the #1 treatment centre for leg ulcers in Europe. The science behind it is basically, normally the oxygen is carried by hemoglobin, and the maximum amount of oxygen is 100%. Whereas what this does, under two atmospheres of pressure, the hemoglobin is bypassed and the oxygen is carried and dissolved in the plasma. And that means you get up to 10 times the amount of oxygen reaching all parts of your body. So you've got 1,000% oxygen. And oxygen is life, oxygen is healing. So it can do nothing else but help. Well, here at the clinic our speciality is leg ulcers. We also help a number of elite athletes with things like soft tissue injuries and fractures, hairline fractures, that kind of thing, and recovering from surgeries, whereas we can actually get the recovery time to speed up to at least 70% quicker than it would do under normal circumstances. If anybody else with an injury, soft tissue injury, non-union bony fractures or hairline fractures or any other sporting injury, we can assure you that we can speed up your recovery quite considerably.
Atmospheric oxygen levels are dropping faster than atmospheric carbon levels are rising. Forget rising temperatures and bigger storms. This is the big problem that neither side of the mainstream debate over environmental destruction is talking about. Peter Tatchell reported for The Guardian back in 2008. The rising carbon dioxide emission is big news. It is prompting action to reverse global warming. But little or no attention is being paid to the long-term fall in oxygen concentrations and its knock-on effects. The effects of long-term oxygen deprivation on the brain are known, and some sound reminiscent of the general rise of stupidity in the industrialized world. Let me show you the effects of having less oxygen.
We'll go ahead and start this demonstration here.
Okay, we're recording, ready to go?
Yes, sir, we are recording, ready to go.
Okay, you can go ahead. Sit that in your lap and just let your hoses hang off to the side there. We're going to drop the mask on the right-hand side of your face, and then when you need to recover, you swing it back up to your face, okay? Since the regulator is on, it may be delivering pressure. Back your hand up for me. Are you there? Go ahead and put it in. He's gone. What do you think?
Okay, folks, that was 1 minute and 33 seconds. Not long, is it?
How do you feel? I'm a little lightheaded. How'd you get your mask on? You put it on me. Okay, do you remember that? Yeah. All right, go ahead and have a chair over.
Okay, are you ready to start on now?
So, I don't know what you think about all of this, but I think we should do some more research on oxygen and maybe the atmosphere and how it used to be, how it's changing. And not only look at the carbon dioxide and not only look at global warming, but look at everything. What do you all think? Let me know. Are you wondering how we can get more oxygen in our atmosphere? It's very simple. In school, they teach you that plants breathe carbon dioxide and give off oxygen as a waste, and that animals and humans breathe oxygen and give off carbon dioxide as a waste. This is true, but they never tell you that plants need oxygen to survive. If you place a plant in an atmosphere without oxygen, it doesn't matter what you do, it will die anyway. Plants take in oxygen and give off carbon dioxide the same way that we do. The difference is that during the day, plants also perform photosynthesis, which turns the carbon dioxide into oxygen. A healthy plant will give off a lot more oxygen than it consumes and consume a lot more carbon dioxide than it gives off. On average, one tree produces nearly 260 pounds of oxygen each year. 2 major trees can provide enough oxygen for a family of 4. Do I need to say more? Plant a tree in your garden, no one can stop you. And instead of taking 20 supplements a day, maybe take a few plants in your living room. There are many studies that prove that it's healthy to have plants inside of your house. Maybe that's how we can fix the atmosphere. If we increase the amount of plants and trees, I think the oxygen level and the pressure will increase. But who knows? I'm just a stupid flat earther. Thank you for watching, everyone, and also thank you to everyone that signed up to FE Friends. It's becoming an awesome website, I love it. Big thanks to everyone and see you next time.